everyone. Oh, hey. Hi, Jeff. I'm going to try and keep an eye on the chat, but I don't even know if I can show my face or not, but whatever. We'll. So I was just moseying around, doing annotations. And I was like, well, I kind of hit like this roadblock. I was like, there's a part in the code that really kind of splits off into all the functionality for its plugins. And so it makes it really complex on how to describe exactly, in sequential order and a teachable order, the different parts, processes that are happening. Oh, what's up, Case? We got another webpack maintainer in the chat room. You guys can say hi to him. So yeah, I'm just gonna, maybe I'll take a couple steps back and jump where I left off at. But I'll put in the chat room for future reference. These annotations will live on github.com/artsy webpack joy. Good times. Okay, cool. So let's jump back to where I last left off at, and we'll hide my cute face. All right, can everybody see? Can everybody see the code? All 5 people. Or at least, screen. That's on my Surface Book Pro that I got. And so I'm going to be using the live pen to annotate. And just an example would be like, oh, wait. Hey, y'all. Oops. Kind of biffed the tip of my pen, so I need to get a replacement. Hey, oh no, let me hit play on live mode so I can see this. Oh yeah, looks like cool. Fun times. So anyways, the last place that I left off was essentially in compilation. So let's jump to it. And so essentially up until, the place that I want to highlight is where exactly or how the hell are we getting to this function right here, an event in the code. And so, because from here, you'll actually notice that there's quite an amount of plugin hooks that are being executed. So, you have this one, these are all Webpack plugin events or hooks, as I like to call them. And then, yeah, so anything that kind of starts with apply plugins, yeah, is some sort of what we call tappable event or that plugins hook into so that they can perform the extra functionality. If you look in the code, you never really see, we want to be able to get to this point and kind of take it step by step. But since there's a lot of hooks here, the one that I'm going to focus on is the optimize modules, I believe, advanced. So let's take a look really quick how we got to this point. And so stepping back one more time is right here in compile. So like this is the compiler. Yeah, it's the, like when you use, like the Node API, so like var equals require I'm just going to shorthand it, require webpack. Oops. This is an example of using the Node API. So you can pass your configuration object, and this is just a function. So webpack, and then your config. So what this returns right here is the compiler itself. So you can think about this as the compile function that gets called internally from other events and hooks. And so essentially up until about right here, this is where all of the dependencies are being built into an initial graph, but we haven't done anything with them yet. Haven't optimized them, rearranged them, sorted them, etc. So we're now at seal. So what the frick? Why did Tobias call it seal? I can't answer that exact question, but I want to, I think that's a good place to trace back from. So anyways, back to the compilation, we see that seal is called, right here. And so from here, what we're going to do is just take a look at the, the optimized modules advanced hook. And the reason why is because there's one plugin, if we look in the code, that references this, and that is actually the flag dependency usage plugin. So the whole purpose of this is to actually mark each module in your dependency graph so that if it has a used export or not, or a used import, it can show, it can allow that tree shaking process to happen as this is quote unquote rendering into real like code that's going to be emitted. So we can just take a really quick dive through this function, and we'll see exactly what's happening. Maybe I'll even turn the screen. Oh, no, we'll start right there. So really, there's not much to it. I want to make these episodes kind of short and consumable, but give you a taste for how to read the code and how to understand it. So why don't we begin? So essentially, we're starting right here, which is where that hook is triggered from the seal function in the compilation. And the compilation actually, or this event, if we were to go back to it, passes an array of all the modules that have been built from this graph. And so the first thing we want to do is essentially we're marking all of these modules with a property called use, and we're going to set it all to false. Assume that we have not tied or made known any of the exports being found yet. So fair enough. And then we have a little queue here, which kind of makes sense. But then let's kind of flow between the different functions that you're going to see here. So first is process module. And the next one is process dependencies block. And I think there's also process dependencies down below. So let's see if I can make this smaller yet still readable. Zoom out a bit. Just gonna check. Is that still readable, guys? Yay, nay? Smaller yet still. Let's see. Turn off my volume. Kind of. I'll make it just a little bit larger. Okay, cool. So we've gotten about this far. We know that we've marked everything as false. So now from here, what we're going to do is just kind of, I'm going to annotate exactly what I see as we're going through, and hopefully this will kind of be a bit more eye-opening for you guys. So like I said, process modules. So for every chunk in Webpack, a chunk is just kind of like the preparation container for what will eventually become files that are going to be emitted. And so you can think of it as if you had a couple of dependency, let's say you have one dependency graph, a chunk can be a subsection of that graph. And so it might just have, you know, some modules in it that reference each other. And it's just, you know, just literally a subtree from, you know, the tree as a whole. So of course, each of these are also going to have modules in them, but we wanted to reference them in chunk format because it's relative to what is available in which chunk. So that's what we start there. And then we also say, well, hey, is this a separate entry point? Like, let's say on page A and page B, or is one of these chunks just like lazy loaded code? So if it is the entry module, the beginning of the graph for that chunk, yeah, I'll answer that in a second, Jeff. So if it is the a entry module, then it's going to go ahead and process it and start looking for used and unused dependencies. So the question was, is there a difference between an entry and a chunk? Yeah, so an entry in itself is just kind of relational to the top of a dependency graph. So in Webpack, there's three kind of layers. You have a dependencies, we can call it module. We'll just say module. So a module which can have, which ties together to other modules based on the dependencies that are used throughout them. But there's always a starting place for your graph. So we would call this the entry. Now let's say, for example, if this has been bundled and Webpack is about to emit files, what you'll notice is that sometimes if you have multiple bundles for different pages without shared code, that you're going to have an entry chunk. And so a chunk is just an encapsulation for that tree that's been made. But the logic used for it allows people, or allows for certain plugins to be able to say, oh, hey, in another chunk, is there, you know, are there other pieces of code that are shared across, you know, different chunks? If there are, move them out into a separate one. But really, you can just think of an entry as being the first or terminal module in the dependency graph, and a chunk itself is just a container for these trees, you know, subtrees or trees of modules. So let's see, where were we? Oh yeah. So if it is the entry module, so if it's the first module, so all entries and chunks, but not all chunks are entries. Exactly. Yeah, there's actually three types of chunks. You have an entry chunk, which contains the runtime, a initial, ITIAL chunk, which is synchronously tied to the entry, but it's split into a separate file. And then there is a normal chunk. So normal is a chunk that is not tied to, it's essentially the same thing as an initial chunk where it's just wrapped in a JSON P, so code is separated into a different file, but a normal one is asynchronously loaded. So the way that this is determined inside the source code is looking at dot has runtime. And that's completely unlegible, but you heard me. And then I think there's a is initial property. And then both of these will be false for this one. So basically where we were was the first thing we want to do is start at the entry. So we just want to start at the first node of the graph, you know. And we have this while function that we're going to come back to a couple times just for reference, but you'll see that it says while there's something in the queue, process this and use this function. So we can put that right here. And then there's also a process dependencies, which is called at this point. And then process module, which we can just reference right here. That's not too confusing. So what we're going to see here is a property called used exports, which lives on the module object, and then also used. And that's, you know, that property we went through and set all the false. So we can basically just say, so in webpack, we have these things called dependencies blocks. And you're going to be like, Sean, this makes no sense. And I'm going to try to make it understandable here. So when we talk about a dependency graph with webpack, we don't treat every export and import as a single node on the graph. And why may that be? So the reason being is that some dependencies can come from the same file or the same, I say file, but it's more abstract from that. So the way that it actually checks in the logic is the absolute path to the location that that dependency exists. And so I'm speaking in vague terms because if we ever wanted to implement something like that, we could tie other different types of abstract containers of dependencies and fit it into a dependency block. So that's what these represent. Like for this example, you could just consider it files. But those are det blocks. And inside of them are dependencies which tie to different blocks. So a block has dependencies, but it also can tie to other blocks inside of here, and so on. And you might say, well, hey, this is actually how async code or lazy loading happens, but I'm not going to dive too deep there. Anyway, so in short, what's happening here is that first we're going to say, hey, is the module, so, you know, for the first time, we're actually just going to pass the entry module and we're going to set true. So if we thought about our queue is essentially at this right now. Entry and true. And then obviously, you know, there's going to be space for more. We're going to start pushing to this queue. But then from here, this triggers our while loop that says, hey, there's an item in here. Let's pop it off. And instead, and then let's call process dependencies block. So like I said, every module is a subclass of dependencies block, or this container of dependencies. So we're processing it here, and it's going to say, hey, for each of these dependencies, oh, hey, Rory, it's going to call process dependency. And then that leads us down here. So essentially what it's doing is it's going to compare and say, hey, well, the reference is, get the reference for the dependency, and then it's actually going to call this function. And so right now it's just comparing locations to say, hey, is this actually used? Does it match the import names from the reference? And kind of like the old used to the new. And then what happens is that at the end, it actually pushes this to the queue. And so now what we have is a flattened set of flat dependencies here. Dep, and then it has the, what was it? Module.used exports. And then if it does have them, it's going to be set to true. So essentially what happens is we have this recursion pattern where if it is a dependency block, it's going to look through all the dependencies. It's then going to process them. And then it's going to go to the next block, which is a module. And it's going to continue to flatten out and push back into this queue until it's full. And so by this point, we now have a full graph that's been flattened into one array. And then for each of them, for each of these nodes, we have a flag that says, is this used or is this not used? And although Webpack doesn't do the tree shaking itself, that's what helps accomplish any of the, it helps tie like your annotations inside your unminified code. I'll just show you a quick example. So if we go to, I think it's export, Harmony export dependency. Let's see. Rory, do you like Harmony export dependencies? Harmony export. Okay. Okay. All right. So while I'm grabbing my high chair, I'll pull up the right file. So let's take a look and see what we got. That's not the one we want. There we go. Okay, so if we look here in this part of the code, Harmony export specifier, when your code is actually output and you're using ES modules and you have, let's say, a function you're not using, you will see extra code based on the isUsed property. And so when the template renders out, you'll find that that code is either an empty function and you'll have that comment there. So hopefully that makes a little bit of sense. I did more talking and over sketching than annotating, but if anybody has comments, now's your chance. Pull up the original file. So if you wanted to revisit this, you can always find the flag module dependency plugin. And that is the flag dependency usage plugin. So hopefully after I finish this, I'm gonna go ahead and put the annotation up on the GitHub, but hopefully you guys enjoyed it. But now it looks like it's time to feed my kids, so bye. I know, buddy. Dad's looking for the off button. Find it. There we go. See you guys.